Well, it is a galvanic skin stimulation device. It is meant to remove the wrinkles in the corners of your eyes. The BioBattery is actually an enzymatic fuel cell. The fuel is actually integrated into the anode structure during manufacturing. So it means that it's a single-use device.
Maybe it was harder to find the ink. Our main task has been the adaptation of this BioBattery concept to printable form. And we have been looking at inks which are compatible with these enzyme catalysts. Also, we have been producing some of the enzymes what have been used in the BioBattery. We started with laboratory tests with a very simple hand coating process. We continued with a laboratory screen printer, and in that process we obtained electrodes printed on A4 sheets. And in these pilot scale printing machines we have been printing currently with a speed of 2 meters per minute. You have to try it relatively fast. But on the other hand, the enzymes don't tolerate very high drying temperatures. So we had to optimize and try in as high temperature as the enzyme could tolerate.
Typically, the battery is printed on a cellulose-based support. There has to be some sort of a moisture barrier. We typically use polyethylene.
I would say that the whole manufacturing method is pretty sustainable.
Ink that contains the enzyme is a carbon-based ink, so it's basically carbon and a very small amount of a binder.
Also, the printing process itself is very environmentally friendly.
Well, sugar is the fuel, so it's carbohydrates and then electrolyte, which is harmless.
So I would say that this is a very green option.
It's made of very cheap materials. That was in fact one of the requirements when we started these projects, was more that not how can we make the best enzymatic fuel cell, but rather that what materials can we use in terms of cost, processability and disposability. And after that the question was, how will we be able to make a battery out of this? But we succeeded.
Biggest added value for the use of BioBattery comes in those applications where you really dispose the whole product.
A galvanic skin stimulation or wound stimulation device, there both the currents and the voltages required are on the same level as what we can already now achieve with the SugarBattery. Well, we are fortunate enough to have started now a pre-commercialization project.
Main issue at the moment is to integrate this BioBattery directly with the product.
And we are planning to have a project that we are aiming to study commercial feasibility for cosmetic pads where we use electricity, and also how we can confirm the effect of that product.
So it is a cosmetic application, but we are quite confident that there is a good future in this.